We like to think that we have mapped every corner of our planet, turning the wild unknown into a series of predictable, digital coordinates. But in the vast, shadowed stretches of the Himalayas or the dense, suffocating green of the Amazon, the map feels suddenly very thin. For centuries, stories have trickled down from the world's most inaccessible places about creatures that defy our modern understanding of the natural tree of life. These are the hidden species, the monsters of our folklore that science calls cryptids, occupying the blurry boundary between biological reality and human imagination. What if some of Earth's largest and most intelligent inhabitants didn't actually vanish during the last mass extinction, but simply learned how to stay hidden? To understand why we are so obsessed with these shadows, we have to look at the massive gaps in our own scientific record of the world. Every year, biologists describe around 18,000 new species, most of them tiny insects or deep-sea organisms that look like floating neon nightmares. But the idea of megafauna, large, breathing, warm-blooded mammals living right under our noses, strikes a different chord in the human psyche than a new beetle. This curiosity isn't just a love for ghost stories. It is an evolutionary remnant of a time when knowing what lurked in the dark was vital. Our ancestors shared the Earth with giants like the Megatherium, a ground sloth the size of an elephant, and the Gigantopithecus, a massive ape. While the fossil record tells us these titans died out thousands of years ago, oral traditions across different continents suggest a much more recent departure. In the Tibetan plateau, the Yeti is not a campfire story, but a historical presence woven into the very fabric of high-altitude mountain survival. Across the Atlantic, in the humid depths of the Brazilian rainforest, legends of the Mapinguari describe a beast with a terrifying, singular roar. These stories are remarkably consistent, often detailing specific anatomical features and behaviors that align with animals we once thought were long dead. When we hear these accounts, we are forced to ask, is the human mind projecting its ancient fears, or is it accurately recording a survivor? The search for the Yeti, or Bigfoot, is often dismissed as pseudoscience, yet it follows the same basic principles as any other biological investigation. It begins with an anomaly, a footprint in the snow that is too large for a bear, or a tuft of hair snagged on a branch. These physical traces act as the primary evidence, sparking expeditions that range from amateur hobbyists to well-funded institutional researchers seeking a breakthrough. In the mid-20th century, the hunt for these creatures reached a fever pitch, fueled by a post-war era obsessed with the frontiers of the unknown. Scientists began to wonder if the missing link in human evolution was not a fossil in the ground, but a living, breathing cousin in the woods. The strongest case for these hidden giants often rests on the sheer scale of the wilderness they are said to inhabit. In the Pacific Northwest alone, millions of acres of dense coniferous forest remain largely untouched by human infrastructure or surveillance. To a small, modern human, these forests are an obstacle. To a large, intelligent primate, they could be a fortress. Eyewitness accounts throughout the 19th and 20th centuries describe encounters that go beyond simple misidentification of bears or elk. These reports often emphasize a bipedal gait, a lack of a tail, and a distinct, musky odor that lingers in the air. Perhaps the most famous piece of evidence is the 1967 Patterson-Gimlin film showing a hairy figure walking through Bluff Creek. While critics called it a man in a suit, biomechanical experts have struggled to replicate the specific compliant gait shown. In the Himalayas, the evidence takes a more physical turn, with relics kept in high-altitude monasteries like the Pangboche scalp. These artifacts were once considered definitive proof, treated with religious reverence and attracting the attention of world-renowned explorers. Even Sir Edmund Hillary, the first man to summit Everest, led an expedition in 1960 to find the abominable snowman. His team found giant tracks in the snow, but as the sun rose, they watched the tracks melt and expand into monstrous shapes. This highlighted a recurring problem. The environment itself is a master of illusion, distorting the mundane into the mythical. Yet, the stories persist because they are backed by more than just blurry photos. They are backed by historical consistency. Indigenous cultures across the globe have names for these creatures: Sasquatch, Almasti, Yeren, each with local variations but a core similarity. These are not portrayed as magical spirits, but as flesh and blood neighbors who are simply better at the game of hide and seek. If they exist, they must obey the same laws of biology as any other animal, requiring food, water, and a breeding population. This is where science steps in, moving away from grainy film and toward the invisible traces of life left in the environment. Modern researchers are no longer just looking for a body, they are looking for the genetic signatures of the unknown. Environmental DNA, or eDNA, allows us to sample a cup of river water and identify every creature that has touched it. We are effectively vacuuming the air and water for ghosts, hoping to find a sequence that doesn't match our database. In 2014, a massive genetic study led by Professor Brian Sykes of Oxford University attempted to settle the debate using hair samples from around the world. For decades, these tufts of coarse, dark fur were the holy grails of cryptozoology, tucked away in jars and museum basements. Using advanced DNA sequencing, the team analyzed 36 samples attributed to the Yeti, Bigfoot, and other legendary primates. The results were a cold shower for many. Most samples belonged to brown bears, cows, horses, and even a few surprisingly common raccoons. However, 2 specific samples from the Himalayas revealed a genetic match to a prehistoric polar bear that lived 40,000 years ago. This discovery suggests that while the abominable snowman might not be a primate, it could be a specialized, relict bear species unknown to modern science. It reminds us that nature often hides the truth in plain sight, using known biological families to create seemingly supernatural encounters. But even with DNA, the lack of a physical specimen, a type specimen in biological terms, remains the biggest wall in the investigation. Science is a demanding mistress. She requires more than just a genetic ghost or a blurry video. She requires a body. If a giant primate really lived in the woods, we should be finding more than just footprints. We should be finding their bones. Think about the millions of deer that die in forests every year. Their skeletons are recycled by nature at an incredible speed. In acidic forest soils, bones can dissolve entirely in a matter of decades, wiped from the earth as if they never existed. When you combine this natural recycling with the extreme rarity of a large predator, the mathematical odds of finding a skeleton drop to near zero. This absence of evidence is not necessarily evidence of absence, but it creates a frustrating vacuum where speculation thrives. To fill this vacuum, researchers look at the ecological niche a creature like Bigfoot would need to occupy to survive. A 1,000-pound primate would need a massive caloric intake, requiring it to move constantly across vast territories to find enough food. We can use computer models to map where these calories exist, tracking berry patches, salmon runs, and elk migrations. When we overlay these food maps with Bigfoot sightings, we see a surprising correlation. The sightings happen exactly where the food is. However, there is a second overlay that is even more revealing. The sightings also correlate perfectly with the density of black bears. This suggests a psychological phenomenon at play, where our brains are wired to see a someone in the dark when it's really a something. This psychological trick is known as pareidolia, the same biological drive that makes us see faces in the clouds or on the surface of Mars. In a survival situation, it is better to mistake a bush for a bear than a bear for a bush. Our brains are biased toward detecting agency. This ancient hardware makes every rustle in the leaves a potential conversation with a monster, regardless of what the camera eventually captures. However, even the most skeptical scientists must reckon with the mapinguari of the Amazon, which sounds suspiciously like a megatherium. The megatherium was a giant ground sloth that stood 6 meters tall, possessed massive claws, and vanished roughly 10,000 years ago. Indigenous tribes described the mapinguari as having a thick, bulletproof hide and a second mouth on its belly, a bizarre, impossible detail. Paleontologists point out that ground sloths had dermal ossicles, bony plates embedded in their skin that would feel like armor to a hunter's spear. Furthermore, these sloths had scent glands on their lower torso that, if flared, could resemble a gaping, foul-smelling mouth to a panicked observer. This raises a fascinating possibility. These legends might not be about creatures that exist today, but cultural memories of creatures that once did. If a group of humans witnessed a giant sloth before its extinction, that story could be passed down for hundreds of generations, slowly morphing into myth. We are essentially looking at oral fossils, biological data preserved in the medium of human language rather than stone or permafrost. Yet, the Lazarus effect in biology shows that species we believe are extinct can suddenly reappear, hiding in the margins of our maps. The coelacanth, a prehistoric fish thought to have died out 66 million years ago, was found swimming happily off the coast of South Africa in 1938. If a massive fish can hide in the ocean for millions of years, could a large primate hide in the deep mountains for a few thousand? The difference lies in the metabolic footprint. A fish in the deep ocean has a lot more room to hide than a mammal that needs to breathe air. As we fill the world with satellites, heat sensors, and drones, the hiding room for any large unknown species is shrinking every single day. We are reaching a point where the absence of a high-quality, thermal-imaged video of a Bigfoot is becoming a significant scientific data point. If they were out there in the numbers required for a healthy population, our modern digital dragnet should have caught a glimpse by now. This brings us to a crossroads. Do we keep searching for the beast, or do we start studying the person who believes they saw it? The mystery of the hidden species might tell us less about the biology of the woods and more about the architecture of the human soul. Perhaps the true value of the hidden species isn't in finding them, but in the search itself, which forces us to map our own psychology. We are a species defined by our capacity for narrative, turning random sensory input into coherent stories about dangers and opportunities. The Yeti and Bigfoot represent the ultimate unknown, a blank space on the map where we can project our hopes, fears, and curiosity. They remind us that for all our technology, we are still primates, living on a planet that is vastly larger and more mysterious than we admit. In a world that is increasingly urbanized, the idea of a wild, undiscovered creature offers a psychological escape hatch from the mundane. If we ever actually caught a Bigfoot, the mystery would evaporate, replaced by cold, taxonomic classification in a textbook. The magic lies in the gap between the footprint and the fable, a space filled with the quiet rustle of leaves and the possibility of the impossible. This is similar to how we treat the concept of aliens. The statistical likelihood of them existing is high, but the evidence is consistently absent. We want to believe that the universe and our own planet is not empty, that we are not alone in the dark. When we stare into the deep woods and imagine a creature looking back, we are actually staring into the mirror of our own evolution. The hidden species are not just biological possibilities, they are philosophical reflections of our desire to understand the limitations of knowledge. They represent the boundary where science ends and storytelling begins, the edge of the known world, where maps stop and legends start. So, the next time you are hiking and hear a strange sound in the distance, maybe it's not a bear or a hoax. Maybe it's just the planet reminding you that there are still secrets waiting to be discovered, if only we know how to look. The search for these creatures is fundamentally a search for the wild part of ourselves that we have locked away in cities. As our technology advances, the physical hiding room for cryptids will vanish, but the need for mystery will remain. We will likely move from looking for monsters in the forest to looking for anomalies in our data streams. The story of the hidden species is not just a collection of tales, but a map of the human desire to explore. In the end, it does not matter if the creatures are real, but that our search for them is real. The true monster, it seems, is not the beast in the woods, but the fear of a world without mysteries. To understand why we are still searching for these giants in the 21st century, we have to recognize the role of anomalous data in science. Throughout history, science has often progressed not by confirming existing theories, but by trying to explain things that shouldn't exist. A single footprint in the snow is anomalous data, a small tear in the fabric of what we currently accept as biological fact. The scientific method demands that we do not dismiss this data, even if it contradicts a lifetime of study and experience. This is why credible institutions, from the Smithsonian to local universities, have occasionally investigated reports of unknown creatures. They are not necessarily looking for a monster, they are looking for a potential new branch on the tree of life. However, the path from anomaly to discovery is notoriously difficult, often plagued by misidentification, hoaxing, and extreme environmental factors. In the case of Bigfoot, the massive volume of sighting reports creates a statistical noise that makes finding a true signal almost impossible. It's a paradox of modern information. The more people look for a creature, the more likely they are to create false evidence. But what if the creature isn't a primate, but a relict population of another hominid species that survived the Ice Age. The discovery of times Homo floresiensis times the Hobbit humans in Indonesia in 2003 proved that human evolution was far more diverse than we thought. If a small, archaic human could survive on an island until just 12,000 years ago, could a large one survive in the mountains? This shifts the search from zoology to anthropology, suggesting that we are looking for a long-lost relative, not a monster. The emotional tension in this search comes from the desire to find something that is simultaneously familiar and fundamentally alien. We want to believe that there is a missing link still out there, a living bridge connecting our modern selves to our prehistoric ancestors. Yet, the absence of physical remains, tools, campsites, or bones remains the most significant counterargument to this theory. Even the most isolated human cultures leave behind a detectable trace of their existence over thousands of years. The hidden species seem to defy this rule, living in the woods without leaving behind the debris of civilization or the bones of their dead. This lack of physical evidence forces us to consider that these creatures might exist in our minds more than in our forests. The search is a mirror, reflecting our own desire to remain surprised in a world that is becoming increasingly predictable. To move beyond speculation, we must consider the environmental constraints that make the existence of these creatures so scientifically unlikely. Large mammals are not just there, they are part of a complex web of energy transfer, requiring specific densities of prey and habitat. A population of only a few hundred Bigfoot would require a territory spanning thousands of square miles to prevent inbreeding and ensure survival. When we plot these habitat requirements onto modern maps, we find that the available uninterrupted wilderness is much smaller than it appears. Furthermore, these creatures would have to compete with established apex predators like grizzlies, wolves, and cougars for the same resources. The competitive exclusion principle in ecology suggests that two species cannot occupy the exact same niche without one driving the other out. If a massive primate existed, it would likely have been seen or even hunted by indigenous populations for thousands of years. Yet, when we analyze the anthropological data, we find that while stories exist, physical evidence like fur, bones, or tools is remarkably absent. This forces us to reframe the investigation. We are not studying animals in a zoo, but the interaction between a myth and its environment. The stories of the Yeren in China or the Almasty in Russia follow a similar pattern. They are local explanations for unknown footprints or sounds. As human populations expand, we are essentially reducing the anonymity of the planet, making it harder for anything large to remain unknown. Modern technology, like satellite imaging and wildlife cameras, is creating a total surveillance of the Earth's surface, down to the meter. The fact that no clear image has emerged from this network is a powerful piece of evidence, even if it is an evidence of absence. This brings us back to the psychological dimension. Why do we feel such a strong need to believe in these hidden creatures? In an era of digital dominance, where we can know the temperature of a planet in another galaxy, the unknown is a scarce resource. The hidden species represent the last frontier of exploration, a psychological space where we can still be surprised by the natural world. They are a reminder of the awe and fear our ancestors felt when facing the vast, untamed wilderness of the Pleistocene epoch. Perhaps we don't really want to find a body because finding the body would mean the end of the mystery and the beginning of a boring catalogue. The search itself fulfills a deeper existential need to believe that our world is still deep, complex, and capable of harboring secrets. In the end, the hidden species are not just biological entities, they are placeholders for the parts of nature we haven't yet categorized or destroyed. Ultimately, the scientific hunt for the hidden species is not just about expanding our checklist of known animals. It is about acknowledging the limits of our own perception and the vast unmapped territories of the natural world. Each footprint, each eyewitness report is a question mark, a gentle nudge from the universe challenging our current understanding. The true danger lies not in the existence of these monsters, but in the potential for a world completely devoid of mystery. If we ever were to catalogue every creature and explain every phenomenon, we would lose the essential spark of curiosity that drives us. The hidden species serve as a necessary boundary, a reminder that there are still edges to the map, however small they may become. We continue to look because we need to believe that the world is more than just data points and satellite images. They represent a psychological need to connect with the untamed, to recognize that we are part of a larger, older, and more complex ecosystem. As we stand on the threshold of a new era of knowledge, we must hold on to the beauty of the unknown. Perhaps the greatest scientific discovery isn't finding a new species, but realizing how much is still left to find. The search for the Bigfoot, the Yeti, the Mapinguari is fundamentally a search for the wildness inside ourselves. In a world that is becoming more connected, the value of the unknown is increasing, not decreasing. So, the next time you feel that shudder of awe in a deep forest, don't look for a rational explanation right away. Embrace the mystery, for it is the mystery that makes the search worthwhile. We are the descendants of explorers, and our urge to find the hidden is written in our DNA. The stories may change, the technologies may advance, but the human desire for discovery remains constant. Let us keep searching, not just with our cameras and DNA sequencers, but with our capacity for wonder. The hidden species are waiting, in the shadows, on the edge of the known, challenging us to keep questioning. And in that questioning, we find not just monsters, but a deeper understanding of ourselves and our place on this amazing planet. The map is not complete, and maybe, just maybe, it never should be.